Welcome! In this lesson, we will build a deep intuition for binomial probability distributions step by step with visuals and examples. The binomial setting has 4 requirements. 1. A fixed number of trials. 2. Independent trials. 3. Exactly 2 outcomes per trial, labeled success and failure. 4. The success probability stays the same on every trial. Think of these like 4 checkboxes. If all are checked, we can use the binomial model. Here is the notation. The letter n is the number of trials. The letter x is the number of successes we want. The letter p is the probability of success on 1 trial. And the letter q equals 1 minus p, the probability of failure. Important caution. The word success is just a label. Make sure that x and p both refer to the same category you are calling success. Now, the binomial probability formula. The probability of exactly x successes is the combination n choose x times p to the x times q to the n minus x. This combination counts how many ways to choose which trials are successes. The factor p to the x multiplies the chance for those successes, and q to the n minus x multiplies the chance for the failures. Here is the intuition for the combination. Imagine 6 trials laid out as 6 slots in a row. If we want exactly 2 successes, we are choosing 2 slots to mark as success. The number of patterns equals 6 choose 2. Let us do a real example. Suppose the probability that a randomly selected adult smartphone owner is cashless is 0.05. We select 10 adults independently with replacement. What is the probability that exactly 2 are cashless? This is binomial with n equals 10, x equals 2, p equals 0.05, and q equals 0.95. We apply the binomial formula. P of 2 equals 10 choose 2 times 0.05 squared times 0.95 to the 8th power. 10 choose 2 is 45. 0.05 squared is 0.0025. 0.95 to the 8th is approximately 0.6634. Multiplying gives approximately 0.0746. So there is about a 7.5% chance of exactly 2 cashless people out of 10. Binomial distributions have simple parameters. The mean mu equals n times p. The standard deviation sigma equals the square root of n times p times q. For our example with n equals 10 and p equals 0.05, mu equals 0.5, and sigma equals the square root of 0.475, which is about 0.689. A quick rule of thumb says significantly low is mu minus 2 sigma and significantly high is mu plus 2 sigma. A quick application of the pigeonhole style bound within binomial thinking. If 9 cards are drawn from a deck, show that at least 1 suit appears 3 times. Think of 4 suits as 4 boxes. 9 cards into 4 boxes means at least 1 box has at least the ceiling of 9 over 4, which is 3. A useful practical tip. When sampling without replacement, if your sample size is at most 5% of the population, you may treat selections as independent for easier binomial calculations. To summarize, check the 4 binomial requirements. Use the formula combination n choose x times p to the x times q to the n minus x, and leverage the simple mean and standard deviation to develop intuition.